Now students, particle acceleration. In order to find it, we have taken equation number 2 from the previous derivation for particle velocity, which is equals to V equals to dy by dt equals to omega a cos omega t minus kx. Now if we differentiate this equation again with respect to t, we'll get d square y by dt square, which is equals to dv by dt, and which is equals to a, which is acceleration. Now this will give us particle acceleration. So differentiating the equation number 1, which is displacement equation, and finding its second derivative, we can get acceleration. Okay. Now differentiate this equation once. So this will give us now cos will now give us minus sine omega t minus kx, and we already have omega a. Now we are differentiating with respect to t, so this will give us one more omega, so this will become minus omega square a sine omega t minus kx. Now if you remember, what does this represents? This is equation number 1, which represents displacement of a particle. So this will give us minus omega square y. Fine. Or we can write a is equals to omega square. Now we can write it in terms of any angle. Fine. So we can write it as omega square sine omega t minus kx plus pi. Now from here, if you take sine pi plus theta, which is sine 180 degree plus theta, is always equals to minus of sine theta. So applying that, we are getting this equation. Okay. Now from here, if we find out acceleration amplitude, or in other words, I can also say the maximum value of particle acceleration, let us represent it by a naught. It is equals to omega square a. Sorry, here a is left. So in this equation, if we know sine 90 degree is 1. So if this gives us sine 90 degree, we are left with omega square a, which will give us the maximum value for acceleration a. So a naught is equal to omega square a, which in turn will give us 2 pi by t. If we put the value of omega, 2 pi by t whole square a. And we can say that acceleration is 2 pi by t whole square times the displacement amplitude. And this particle acceleration is ahead of particle displacement by pi radian, by an angle pi. Okay. If you remember, velocity is ahead of displacement of the particle by pi by 2 radian, but here acceleration is ahead of displacement of the particle by phase pi radian.